Hello everyone and welcome to this channel. If you are new on this channel, kindly subscribe, hit the notification bell so that you get notified anytime we post such a video. This video is coming from KNUST College of Engineering, Department of Chemical Engineering. And then in our presentation, we seek to present on the production of bioethanol. In this presentation, we are going to talk about the chemistry of bioethanol and the application of bioethanol, the process in bioethanol production, the bioethanol production plant, and computer hardwares and softwares needed to optimize bioethanol production. Stick with me till the end. Let's roll. Bioethanol, chemically written as C2H5OH, is a renewable alcohol-based fuel from cassava, sugarcane, and other starchy foods. It belongs to a group of compounds called organic compound, specifically alkanols. At room temperature, ethanol or bioethanol is liquid. Applications of bioethanol include 1. Fuel blending with petrol to reduce emissions, solvents in pharmaceutical and cosmetic industries, disinfectant and sterilizing agents, feedstock for chemicals like ethylene, and many others. Here are images of bioethanol application. First one, bioethanol as fuel, seen in states and countries like China, Brazil, US, and India. In the pharmaceutical industry for drugs and paint industry also for paint making. You would also bear with me back in 2019 during the era of COVID-19 that ethanol became useful to the world at large, since it was one of the active ingredients in the hand sanitizers we used at that time, just like isopropanol. Let's roll to the processes in bioethanol production. The production of bioethanol follows a structured sequence of processes including feed preparation and grinding, liquefaction, saccharification, fermentation, distillation and dehydration, storage and or distribution of ethanol and its byproducts. In our presentation, we will focus on the production of bioethanol from cassava. Let's take each of the process and look at it into details. Feed preparation and grinding. Here, cassava roots are cleaned, peeled, crushed, and then refined into a pure starch milk that is then dewatered and dried into quality cassava starch. So here is our image of freshly harvested cassava that will be later cleaned, peeled, crushed and grind for the production of bioethanol. The next stage after feed preparation is liquefaction. In this step, water is added to the cassava starch and cooked down into a gravy-like substance called slurry. Then, the liquefaction process begins with partial hydrolysis to lower its viscosity. In order to do that, an enzyme called alpha amylase is added to the slurry to break down the long-chain starch into smaller ones. The next stage after liquefaction is saccharification or hydrolysis. In this step, glucoamylase enzyme is provided under controlled conditions of temperature and pH to convert the cellulose and the starch into simple sugar molecules, usually glucose. So here is our equation where starch is converted to simple sugar and monosaccharide glucose for further process to take place. After saccharification is fermentation. It is in this stage where ethanol is produced. The mixture after saccharification is cooled and then yeast extract is added to allow fermentation. Common industrial yeast called Saccharomyces cerevisiae in the yeast becomes activated and then by microbial activity, specifically anaerobic respiration, breaks down the glucose into ethanol and carbon dioxide. So here is our equation where 1 mole of C6H12O6 breaks down to 2 moles of C2H5OH and 2 moles of carbon dioxide. Our ethanol is produced and the next stage continues. After fermentation is distillation and dehydration. Since carbon dioxide was already emitted during the fermentation step as a gas, only water is left with ethanol. Therefore, distillation is done to evaporate the remaining amount of water, yielding anhydrous ethanol. In some industries, the carbon dioxide is collected into a gas holder and later sold to brewery industry for the production of soft drink. For the distillation process, the mixture of water and ethanol in our distillation column is subjected with heat, where ethanol with a boiling point of 78 degrees Celsius is first to evaporate, leaving behind the water. The ethanol is dehydrated and then collected into a storage tank. The final stage is distribution or storage. The ethanol is distributed to various industries or stored and later distributed. The ethanol is used by industry, specifically in the transportation, as fuel or mixed with diesel for vehicles. In the pharmaceutical industry for drugs, hand sanitizers, disinfectants, and many others. Besides ethanol, byproducts include dried distillers' drains sold for animal feed production, biogas used as a supplemental energy, and carbon dioxide collected for sales to the beverage industry. So in a summary, this is a comprehensive presentation on the production of bioethanol. Now to our production plant. So this is the process plant for the production of bioethanol. Here we present our customized design process flow diagram, showing all key operations, equipment, and order in which they occur. So as we can see, this is our starch source. After grinding, gets into the slurry tank where liquefaction takes place, and then to saccharification, fermentation, distillation and dehydration, and finally to storage. From cassava handling through to ethanol production and storage, this diagram reflects a real-world industry setup customized for Ghana and any other cassava abundant region. Now to the computer needs of the process plant. Computer needs include input devices such as sensors, example carbon dioxide sensor, thermocouples, face recognition scanner, output device or control device such as alarms, HMI screens, UPS as power backup, that is uninterrupted power supply, CCTV cameras. Softwares include stimulation software such as Aspen, automation and process control softwares such as SCADA and Wonderware. Having input device like carbon dioxide sensors help us to detect that indeed our fermentation process is taking place. Thermocouples help us to provide optimum temperature for the activities of enzyme. Software such as simulation softwares will enable us to test our processes and system virtually before we run them. It also provides the model for us to test the effectiveness and the level of efficiency of the machines that we will use in the process plant. In conclusion, this project offered a full conceptual design for producing bioethanol from cassava. We have shown how biological science, chemical engineering, and digital automation come together to produce a renewable, clean, and economical viable fuel. This project was compiled by Tender Edward, Julian Entry Kofi Bona, and Kwe Lovina from KN University. Thanks for watching. Once again, don't forget to subscribe, hit the notification button so that you get notified anytime we post a video. Comment below and see you in the next one. Bye.